So the final step for this exam is to create a subplot, and then create a scatter plot of the experimental data that we simulated in the steps above. And then finally, we want to make a mesh wire grid plot to model our data that we plotted. So the first step in order to do this is to create a figure and then make a subplot. So I'm going to say fig, short for figure, is equal to make subplots. And then I'm going to leave this argument open because there's nothing I need to customize in there right now. And then after we do this, I want to add a trace to the subplot, which will create our 3D scatter plot. So fig.add_trace. And then I want to create a 3D scatter plot, so I'm going to say graph objects.scatter3D, and then in the argument of this, we want to define x as the Reynolds number, y as the Schmidt number, and z as the Sherwood number. I also want to customize the style of the points that we're going to be creating. So I'm going to set the mode equal to markers. And then we can also customize the style of these markers. So I'm going to I'm going to hit Shift Enter and see what this looks like. Okay. I'm going to hit Shift Enter and see what this looks like currently. So I think that these markers look really big, and I would like to change the color of them. So we can customize this by saying that marker_size is equal to, let's say, 4. And then I'm going to say marker color is equal to the Sherwood number. And this will create different colors of the marker based on the value of the Sherwood number. So we hit Shift Enter again. I think that this plot looks a lot better. We can see that the Sherwood number markers have different colors, and the marker size is a lot more appropriate for this graph. So after we do this, we have all of our experimental data plotted, so we just need to create the mesh grid plot. So I'm going to create 2 new variables, the Schmidt grid and the Reynolds grid. And then I'm going to use the mesh grid function within NumPy. And I'm going to do this to create an array of linear spaced data points for the Schmidt number and the Reynolds number. And during this one of the values will be kept constant and the other will be varied, and this will create horizontal and vertical points on our graph. So for the Schmidt number, we're going to say that we want linearly spaced data, so numpy.linspace, and then we're going to define our upper and lower bounds for this. So we know that the Schmidt number is valid from 0.6 to 2.5, so this will be our upper and lower bounds. And then I'm going to say I want 40 different points. And then we'll say the same for the Reynolds grid, so we'll do numpy.linspace, and then this is valid, the Reynolds numbers are valid from 2,000 to 35,000, so I'll define these as our upper and lower bounds. And then I want 40 points for this as well. And then after we do this, we need to create the Sherwood grid points by saying by using the Sherwood-Gilligan correlation up here. And then I'm just going to replace the Reynolds number with Reynolds grid and Schmidt number with Schmidt grid. Cutting and pasting is just a little bit easier. So I don't have to type everything out again. Okay. And now that we do this, we need to create the lines and trace for this. So we need to create our lines. So what we want to do is we want to use the zip function, and this will pair the values of the Schmidt grid, the Reynolds grid, and the Sherwood grid. So it'll pair the first values together, the second values together, and so on. So for 3 random variables, I'm just going to call it ABC just for simplicity in zip, and we want to zip the parameters of the Reynolds grid as the A value, the Schmidt grid as the B value, and the Sherwood grid as the C value. And then once we do this, we want to add a trace for this. So we're going to go fig.add_trace once again, and we want to add this to our 3D scatter plot. So go.scatter 3D, and we want to say x is equal to the A value, b is equal, or y is equal to the B value, and z is equal to the C value. And then we're going to define the mode as lines since we want this to be a mesh grid. So we're going to say mode is equal to lines, and I'm going to say that line width is equal to 1 since I want these lines pretty skinny. And then line color I'm just going to set as gray just so that they don't overshadow the colors of the Schmidt or the Sherwood numbers. So line color equals gray. Okay, I'm going to hit Shift Enter. Everything seems to be correct. So we're going to move on to creating the vertical lines. So for this, we're just going to switch the order of the mesh grid for the Schmidt and Reynolds grid. So I'm going to copy and paste this down here, and we're just going to switch the order. Now this will vary the other parameter and keep the other the same. So Reynolds grid, Schmidt grid. So this will create lines perpendicular to the ones that we just created. And we just need to switch around the order in here. And the rest will be kept the same. And then we need to create another zip function for this as well. So I'm just going to copy this down here. Should be the same. Make sure everything no typo has any typos in it. And then I'm finally going to update the layout of the plot. So we're going to go figure.update_layout, and this will generate the plot and allow us to customize the plot. So the first thing I want to do is I'm going to give the x-axis titles. So I'm going to set the scene equal to dictionary, which will reset the default values, and we can redefine them. So I'm going to say x-axis _title is equal to the Reynolds number. The y-axis title is equal to the Schmidt number, and then the z-axis title is equal to the Sherwood number. So after we do this, I'm going to hit Shift Enter. and this should generate our plot. Okay, so something is wrong here. And I'm going to say show legend equal to false, and this will get rid of these trace lines on the side. Okay, so I'm going to try to see what is wrong here. So go scatter 3D, markers, Sherwood grid, figure add trace, and space. So I'm going to copy this and see if I can get this plot to work again. So there's something wrong in this line here. Make sure everything is executed up above. Okay, there are our plots again. So something must have gotten messed up above. And we are going to try this again. So fig.update underscore layout. Scene is equal to dictionary. I'm going to redefine that. So x-axis underscore title is equal to Reynolds number. Y-axis underscore title equal to Schmidt number. And the z-axis underscore title is equal to the Sherwood number. We're going to turn off the show legend. So show legend equals false. Okay, let's see if this generates our plot now. Okay, so here we have our plot. We have the Reynolds number on the x-axis, the Schmidt number on the y-axis, and the Sherwood number on the z-axis. And you can see that the mesh wire grid correctly models our data points and fits them really well. All of the points are not directly on the mesh grid because they account for the 10% normally distributed error in our data. And we have everything correct. So I'm going to update the height and width of the graph just because I want it to be a little bit bigger, and then we will be done with this. So I'm going to say width is equal to say 900, height is equal to 900. So it seems that something got messed up again. So we can try this one more time. Okay, so here we have our final graph, and it is exactly how we want it to be. So that is the end of exam 2. Thanks for watching.